Cool. Yep, I'm back. Let's see, is everything working? Everything should be good. Background music is good. I think it's good. Just let me know if it's too high. As always, hey Tammy, how's it going? Nice to see you here again. Nice. Okay, I see everything's going good. Let me get the first thing, which is you can all register here, please. There you go. Nice. Awesome. Cool. So, let's see. What should I do first? Maybe this. Cool. Cool. Awesome. So this is part 2 of, maybe I should put it like this. Share my entire screen. Yes, please. This one right here. There we go. 3, 2, 1. Ah, there it is. Cool. Okay. Hey. Oh, it's beep beep. Hey, beep beep. Cool. Awesome. So train an autonomous vehicle with PyBullet part 2. Okay, because we did. Tammy was last time with us. We did part 1, which we basically understood what PyBullet is, what it does, what it's used for. And just in case people don't know who I am, well, my name is Charbel. People call me Bully. I'm a robotics and telecommunications engineer. I live in Puebla, Mexico, which is in the center part of Mexico. I was a fellow back in 2021 for batch 3 for production engineering. And I've been a pod leader ever since. I am also the program coordinator at the fellowship in MS Junior. So yeah, cool. There are my socials in case you want to connect with me. I'd be happy to connect with you. Okay. By the way, on Discord or LinkedIn, if you want to send me a message, just ping me like 1,000 times because I usually forget. But yeah, awesome. Cool. So let us start. We won't get to the PPO right now, so let's just take it where we left it last time. Yeah, this should be good. Let's see. Let me rerun this and see what happens. I don't have an ENV here, so as always. Oh, by the way, this code right here, this one that I'm going to start with is the one that we finished last time. You can find this code in my GitHub, which is this one right here. Okay, you can find all of my Global Hack Week streams codes there. Okay, I'll just send it here. Cool. Yeah, just copy this entire code, and yeah, nice. Okay, actually, this is a bug. This is a 1 instead of a 2. Okay. Well, let's see. Oh, nope, it should be Visual Studio Code. There we go. Cool. Okay, so first of all, first bug that I see that I corrected last time, it's not I plus equals 2, it's I plus equals 1. Okay, that's the first one. The second one is let's see. Yeah, this should be good. You can see all my notes here because this is my this is the template that I used last time. Yep, there we go. Cool. Okay, so what does this code do? Okay, just a brief explanation, quick explanation. This creates a plane. It loads a lidar as a sensor for our robot, and then we generated a robot called R2D2, which should be here, with the spawn robot function. And then we have some points to draw some walls. Okay, that's the function that we did, or like that's the class that we created last time. Okay, that's what it does. So what we want to do now is correct some things that I got wrong last time. Okay, let me just see what I corrected, which should be in this app right here. Give me a moment. My iPad is 10 years old. I don't use it anymore. I use it for university, to take notes with the Apple Pencil and everything. But yeah, like it was old even when I was at university. Like I got it 9 years ago, and I started university 6 years ago, and I finished a year ago. So yeah, awesome. Okay, cool. So this one right here, let me check. Yeah, for an iPad, yes. You know what? I don't like Mac or anything about Apple, but the iPads rock. Okay, let's see. Just give me a moment. Let's see what I changed here. Yeah, this should be good. Okay, I think I'll get I forgot what I had to change. Okay, just in case, if we have any bugs, I have it here. Okay, cool. So now we want to create a racetrack. Okay, we don't want to create a very long racetrack. It doesn't make sense. Okay, we won't have enough time to train our reinforcement learning algorithm, but we will see how it works in a very short or small box. Okay, so it doesn't hit the box. Okay, cool. So in here, instead of these points, we're going to add the following. Okay, and I'll draw them in a minute and tell you why. Okay, -2, -2, -2, 4. All should be tuples, by the way. Oh, my bad. Then we do 24. Then we do 20 -2. And then we do -2, -2. Okay. Now, why is that? Because let's get paint. There we go. Cool. So it's a box, okay, like this. Our robot will spawn at 0, 0. Okay, so here 0, 0. This is the car. Okay, this is 0, 0. Now, if I spawn the walls just right here, the robot will be either inside of the wall or on top of the wall, something that I don't want to happen. So I added the first link of the wall to be -2, -2, which is this. Actually, no. It's this one right here. So this is the first point. The second point is -2, 4. Okay. There we go, 4. Then the next point is 24. And then the next point is 20 -2. Here. And then we go back to -2, -2. Okay. So that's why we have these points. Okay. Cool. So let's see that happen. First of all, careful. We always need our virtual environment. Okay. And by the way, if you have any questions, just let me know on the comments, and I'll try to answer them as best as I can. And if you're new to Python or not very familiar with things that I say, just let me know. Okay, no worries at all. Cool. I go to the desktop. I go to PyBullet stream. Should be part 2. There we go. In here, if you are in a Windows machine, you should run py-m-v-n-v-env. Okay. Remember, v-and-v, this is the whole command. Okay. After this is the name of your environment. Okay. I usually call it env. It's the easiest way to call it. Okay. py-m-v-n-v-env, run this, and give it some time. Come on. Yeah, now it's taking a lot of time. My computer is not connected. Wait a minute. There we go. Cool. Let me just connect my computer real quick. Because this computer just eats electricity. I have an RTX 4090, and it just consumes everything. Okay, cool. Now, if you are on a Unix-based machine, which is either Linux or Mac, you have to run Python 3-m-v-n-v-env. Okay, remember, this is your command, and this is the name of the environment that you'll give. Okay, so it can be python-mv hello, okay, or python3-mv virtual environment. Okay, it depends on what you want to call your virtual environment. Okay, cool. Now, if I run this, it'll throw an error. Okay, so no running this. If you want to activate your virtual environment, you have to run in Windows env scripts activate. Okay, env being the name of your environment. Okay, in this case it's env, so it's env scripts activate. Okay, it should run. Nice. And you can see here it says env in green. Okay, maybe I'll zoom a little bit in. There you go. You can see env there. See, ignore the base. Okay, this is conda. We won't use conda for this, but env here. Okay. As for Unix-based machines, you have to do source env to bin and then /activate like this. Okay, it's / here, so you do like this: source env bin activate. This is for either Linux or Mac. Okay, cool, nice. So now that we got this working, let's run this. Okay, so we have to pip install PyBullet. What else? In the meantime, we have to. Yep, the PyBullet for now is good. Let's see, it's cached already, so it shouldn't take that much time. Maybe in your computer, if it's not cached, it will. Okay. Cool. Now, to run this, we run it as a normal Python program. Okay. Let me just double check if because also the fans in this computer are horrible. Do I have echo, reduce background noise? Yep. You're good. Just let me know if you hear something weird. It's my event, like the fans of this computer. It's in gaming mode, which is the best performance, but I can just reduce the performance a little bit so the fan doesn't activate each 2 minutes. Okay, cool. So now that this is running, we can do PyRobot class. Okay, let's see what we have. And we don't have what I wanted. Okay, we have the first point, but we don't have what I wanted. Here's R2D2, and here's a lighter, which we'll fix in a second. Okay. Cool. Let's go to create walls, and here solve the track points. I+1 should be here. So the period equals true. This is irrelevant for now. Let's see. Apply motion to car. No, this is not it. Yeah, should be good. Where's the error? I think it has to be in the list. Wait a minute. I think you got it wrong. It has to be in the list. I think. I don't think so. Nope. No. Where was the error? Because I spotted it yesterday, and I was like, hold on, that's not supposed to be there. It's not creating it. P0, P1. Yeah, it should be good to go. Yes. Let me just print points. Let's see what this is. Let's debug real quick. Okay, that's weird. It prints. It creates like the wall, but it doesn't put the wall. Wait a minute, I'm just going to give me a second. Yep. Y'all can see this. Yeah, it's. Where can I see it? Where are the fans? 97 degrees in my CPU. That's not good. Why? Yeah, that explains my fans being so okay. Let's use this mode. Yeah, that wasn't good. Yeah, that I didn't like that spike. That's a weird spike. Going more than 80 degrees is not good. Okay, Cool. Let's leave it there. Nice. So let me just real quick check what is going on. Yep, track points, track points. Did I override track points here? No, track points should be good. So for track points. Real quick. Yep. Well, I is less than, so the track points in 0. Oh, I got it. My bad. It's I and I plus 1. Yep. My bad. Yep, we were just using 0 and 1 instead of keeping track of I. Okay, so again, the correction is I and I plus 1 here. Okay, yeah, I forgot. Cool. Now this should give us a box. No box. Out of range. What? Oh yeah, it's -1. So I less than length -1 because we're also looking at the next item. Okay, so that should be good. Yeah, there we go. Cool. Now you can see this is working. Okay. Now, interesting enough. Remember last time this was super slow? Turns out that it's not the processing. It's actually my screen. So check this out. In the screen, the one that I use in front of me, that's not my computer, which is the one that you're looking at right now. It's slower than if I have it there with you. So it's weird, okay? I'll share the other screen later, okay? But yeah, you can see this is the box that we drew. The robot has to not collide with the walls and go forward. Okay, that's the first or like the rules that it has. Okay, cool. Now, let's start with defining how to move the robot, right? Because we haven't moved the robot here, right? Run simulation. Yep, we just added a sensor last time, but we don't have how the robot moves, okay? So def apply motion to car like this. Self, we need a throttle, and we need steering, okay? Always please comment your functions, okay? Easy function that applies motion to a car. Front wheels are going to steer. Back wheels. What's wrong with my spelling today? Back wheels are going to drive. Cool. Okay. So let's see. Okay, cool. We'll pass, we'll return in this, so it doesn't return an error. And in here, let's just take a look at what the joints are going to be, the ones that we're going to edit, okay? So, for I in range, p dot get num joints stuff the box ID. Okay, if you don't remember what box ID is, it's our robot. Okay, you can see it here. Box ID is the robot. Okay, cool. Let's go back. Where's the error? Oh, there we go. Cool. Now inside of this, we'll do print I, and then by the way, first we need info equals p dot get joint info like this, self dot box ID. Okay, we get the information from the box, which is our robot. In here we do print I, so we know the number of the joint, and then we do info in 1, not in 0, in 1 dot decode. Should be UTF-8. Yep, should be good to go. Let's see what we have. Oh, by the way, we don't need R2D2. We're going to use race car, so it should be race car slash race car like this. Okay, let's see. Interesting. Joint index missing organic joint index 150. What? Say what? Info. Get joint info. Oh, my bad. We have to add the I here after this part, okay? So it's p.get joint info, self the box ID, comma, I. Okay. And there we go. They should be good. Okay. You can see the car. You can see it's race car. Yeah, it's a tiny car developed by MIT that exists in real life. Okay. This car is going to be the one that's going to move by itself. Okay. In here you can see our base link joint, which is the blue thingy here, is number 0. Chassis inertia joint, I guess it's a box inside of here. It's 1. Okay, and you have here all the joints. We're interested in joints 5, 7, 6, and 2 and 3. Okay, so 2, 3, 5, 6, 7, and 4. Here's the steering hinge. Okay, so we need to control the hinges and we need to control the tires. Okay, if you don't control the hinges, it'll just slide. Okay, let's see if I can show you how it slides today. I don't want to take too much time. But yeah, I was stuck in that bug yesterday. Okay, so we go to this part right here. Inside of here, we'll do 4-wheel in 2, 3. We said 5 and 7. Yes, these. Yep. We have to do p.set joint motor control 2. Okay, why control 2? Because it's in 2 dimensions. Okay, it's not going to fly. It's going either X or Y, but not Z. Okay. Inside of this, we're going to add self-led box ID. We're going to add the wheel, which is in this case either 2, 3, 4, 5, or 7, which are the wheels. Okay. P dot velocity control like this with L, not that letter. Target velocity equals throttle, the throttle that we have here as input, and then force equals 80. Okay, so let me explain this because this is a lot. We don't have a lot of time, so I cannot show you how the car slides as the error, but this is an AWD, which is an all-wheel drive. Okay, it means wheels are going to, all 4 wheels are going to spin. Okay, you can have, I think it's, is it B or RWD? Car fans, do you know? Rear wheel drive. There you go. It's RWD, where the back wheels are the ones that push the car. We also have, I think it's FWD, which is the vehicles that have the strength or the engine in the front. Okay, it's the one that pushes the car. And we have all-wheel drive, which is basically 4 wheels. Okay, if we add either 2 front or 2 of the back, the car doesn't have enough strength to go in front and turn. So that's the solution. Okay, having your car in AWD mode. Okay, which is all-wheel drive. Cool. So that's what we did here. Wheels 2, 3, 5, 7 are going to have motion control or motor control in this case. Okay, cool. So now this is for moving, and now I see a question there. I know nothing about cars. That's okay, Tammy. You know what? I don't know that much about cars either. But you know what? When you do projects like this, you kind of, learn just because you get to that error where your car doesn't move, or it moves but it slides and it doesn't turn. So you have to read a lot, and that's how it is. But yeah, cool. Okay, add steering. Cool. So 4-wheel and 4-6. In here, we're going to do p dot set motor control 2. And inside, first we select our robot. Okay. Then we select the wheel. And then we say, hey, in this case, I want you to have p dot position control. Okay, what does this mean? You can see the difference: velocity control and position control. One moves the car and the other one will only rotate, won't rotate in the front, it will rotate in its axis. Okay, cool. And the force here is going to be equal to 50. Okay, after trial and error, yeah, those are the numbers that I got. Cool. Okay, nice. Now we can move the car. Okay, the car is movable right now. Let's test it out. So let's do control with keyboard. Okay, always test your code. Okay, even if you have to program a little bit more, make sure that you test your code before, especially when you're simulating stuff. Okay, so you know that it works. Let's do pass self here. Force function to control the car with the user's keyboard. Like this. Okay. So first of all, we need to understand or listen to our keyboard. You do this by doing keyboard. Okay. So keys equal to p dot get keyboard events, like this. Okay, so that's the first thing. We're listening to our keys, saying, hey, if something gets pressed, I'll record it. Okay. Now let's add throttle and steering, like this. Throttle equals 0, steering equals 0. Okay. So let's listen to our keyboard's arrows. Okay. Move the car with arrows. So if p dot b3g up arrow, like this, in keys, it means, hey, if whatever I pressed, one of them was the up arrow, then throttle is going to be 1. Let's do 20. Okay, 1 was too slow. Let's do 20. Like this. Okay, that means go forward, right? If same thing, p dot b3g down arrow in keys, yep, like this, then throttle equals -4. Okay, obviously 0 is stop, 20 is go, let's say 20 meters per hour. Let's say -4 is don't go in front, go in the back. Okay, start steering the contrary. Okay, in the opposite way. If p dot, again 3, it's b3g left arrow in keys, then steering equals 0.5. Right? We kind of turn the wheels just a teeny tiny bit. Okay. If p dot b 3G left, I'm sorry, right arrow in keys, then steering becomes minus 0.5. Okay, we're steering to the opposite side. Okay, cool. Now, after this, if we recorded something, self.apply motion to car. Okay, so this function, which we previously wrote, it's going to make sure that we send the signal to the car saying, hey, I want you to move. Okay. What are we going to send? Of course, throttle and steering. Okay. So far, so good. Cool. So if we go up to not this function, this one, it's easier to find. It's the one called run simulation. Okay. Cool. Oh, my bad. There you go. 1, 2, 3. Okay. So we have create walls. We have to create the walls before loop. If not, we'll create infinite or 10,000 walls. Okay. Gets rid of this because we won't be using a camera. I think I'm going to add this just so it's smoother for you to look at it smoother. And then we have to control. And we have to put it here, okay? Not outside of the loop, inside. If not, it won't register the keys, okay? So we do self-diff, control with keyboard, like this. And yeah, voila, should be good. Let's run it and test it. Okay. Get keyboard events, get keyboard, careful. Missed an R there. Keyboard events. I always say it. Please do not run away from errors. Read them. Yeah, it makes you a better coder. Okay, cool. Another one. Velocity control. Did you mean velocity control? Huh. Really? What's the difference? Velocity. Velocity underscore control. Oh, that's weird. What? Really? What's the error? Wait a minute. P dot velocity control. What? Velocity underscore control. Wait, what? Wait, it's kind of sensitive. I don't think so. Small L at the control. Thank you, Ireland. Yes, lowercase L. Thank you, beep beep. Yep. No. I see it. I didn't see it at first. Thank you so much. Do I have something here? Control capital L. Yep. Okay, shout out to everyone. Thanks, Tammy. Thank you, Ireland. Thank you, Ireland. And thank you, beep beep. Yep, you got it. Got it. I don't know why they. Oh, again? Set joint motor control to set. Oh, I missed the joint there. Set joint here. Capital J, okay? Careful. Set joint motor control to. Okay. Let's see. Ah, there we go. Cool. So technically, this should work. And it's working. I'm pressing the up arrow. It's moving horribly slow, but it's moving. Okay, let's steer to the left. Awesome, it doesn't steer. Let's steer to the right. It doesn't steer. Can we go back? It goes back. It doesn't steer. Interesting. Left, right, left, right. What happens if I put it here? Yep, nope. It doesn't steer. Okay. Left arrows and keys. Okay. Oh, that's weird. Steering. Yep, I activated here. 4-6 should be good. Isn't it 4-6? Did I get it wrong? No, it's good. Oh, wait a minute. Wait a minute. I didn't put a position. Yeah, in this case, it's target velocity throttle, but I don't have a target here. It's missing the target. The target is 0. I never overwrote the target. So it's target. My bad. Position equals steering. Okay. Yep, there we go. Comma there. Okay, yep. We got that right. It says target position, steering. I didn't add the target position. So by default, it's 0. So whenever I clicked or hit on the keys, it didn't change anything. Let's see it again. Should work. Okay. Okay, it steers now. Can you see that? Okay. It's a little bit laggy again because of the screen. If I put it in my computer screen, it's different. There we go. See that? I can move it around. Okay. Cool. Now we have an error. Okay. LiDARs are usually 360 degrees. This doesn't work for us. Okay. We need to know what's behind us, what's at our left and right, and what's in front. Okay. And this LiDAR looks like a 45 degree. No, it's like a 90 degree angle. See that? It's kind of 90 degree, maybe a little bit more. So let's fix that. Okay. The fix is going here where it says place sensors in LiDAR. Here it is. The spread angle is 90 degrees. I think it has to be math.pi times 2. Yep. It's math.pi. Pi in radians, which is in angles, is 180 degrees. Okay, so it's half a circle. Okay, so a half a circle times 2 times I, which are the number of rays. I'm sorry, times wait a minute. Number of rays. Ray length. This has to be inside here. This has to be here before the angle. Over num rays. This should create a circle. And this is 360 degrees. Okay, we want the number of rays to be a little bit more. Let's do 36 rays in total. Okay, awesome. Let's keep the length as 10. 10 should be good. Okay. Yeah, good. Yeah, should be good. 180 times 2 times I, which is the number of ray over number of ray. Okay, so we get the specific angle of each one of the rays. Okay, let's see that. There we go. No, we don't got it. It's kind of like 180 degrees. What? Why? Math of pi times 2. Oh, we got it. Wait a minute. No. I'm doing it here again. This doesn't make sense. This here has to become this. So your angle becomes this. Yeah, we calculate the angles twice. We don't have to do that. Math of pi times 2, which is 360, times I, which is the number of the ray, over all number of the rays, so we get the exact position. Okay, should work now. Yeah, there we go. Cool. See that? It looks weird. There we go. Oh, camera's horrible in this thing. There we go. See that? It turns 360. Okay, and you can briefly see the ones that are in front are green because the ray length is 10. And in 10 meters, we don't see anything. Yeah? Even though it hits here, you can see this is the limit. So at least here it doesn't hit anything. If we go forward, maybe it'll hit something. There we go. It became red. See this one? Yep. Looks like a flashy thingy. Comet, maybe. I don't know. Cool. Okay. That's the LiDAR fixed. Okay. Cool. Now, create walls is good. Motion the car, control with keyboard, and run simulation. All should be good. Awesome. Now we have our first part, or let's say that our simulated yeah, let's call it simulated. I'm trying to find a new word, but it's like the simulated electronic robotic part of this step. All okay. We have it moving. Close up time. We have it moving. We have it. We can control it. Okay. So if we can control it, a machine can control it. Okay. We saw that it works. Now let's have the machine do it. We can create a track. Okay. We created a rectangle. You know, as for now, it's good. And yeah, we have the lidar that it's 360. Okay. For now, good. Cool. Close up time out. Awesome. Now, let's go to a new file and let's create an AI class. Now, why would I create the AI class outside of this one? It's good practice to have your AI isolated in one class and your simulation in the other. That way, if this one works, if the other one has an error, you know it's not this one. Okay, for now, this works. Okay, so we don't have to mind or worry if and double check every single part of the code again. This works. Let's just connect it. Okay, and it's way easier to understand. Okay, cool. Now, for AI class, we need to understand some mathematical things. Let me just take a quick look at this. Yeah, should be good. Yep, we should be good. Okay. The logic behind what I'm going to do, or what we're going to do actually, is, hold on. Let's go. Is we have our PyBullet here, okay? PyBullet. PyBullet is here, okay? PyBullet runs the simulation, runs the robot, and yeah, it has the lidar and it has the whole environment, okay? We're going to use something called PPO, okay? It stands for, I forgot, wait a minute. Proximal policy optimization. Okay, that's what it's called. I'm explaining this in a second. Okay, and PPO runs only, or the one that we're going to use, runs in Gymnasium. Okay, it's OpenAI's open source simulated environment for reinforcement learning. Okay, so what we're going to do is PPO and PyBullet sadly are not compatible like this. So we have to add sort of a wrapper, something over PyBullet. Yep, extract the lidar, extract position, and extract movement, okay? There we go, movement. Okay, that's what we're going to feed the PPO. Yes? And in return, we're going to do something interesting. We're going to say, hey, Mr. PPO, if you go backwards, okay, if you go backwards, you get punished. Okay, if you hit a wall, you get punished. But if you go forward, you get let's say the reward. Okay, and we also reward it if it stays alive. Okay, so we punish the model if it either goes backward or hits a wall, that's a big no-no for us. We wanted to drive alone. We wanted to go forward because being a greedy algorithm, it finds a way to not move and say, hey, I'm staying alive. Someone is paying me to stay alive, then I'm just going to do it. Why move, right? We have to stay alive and we have to move forward. Okay, those are the conditions. Okay, so PPO calculates this, and based on this whole thing, it'll feed PyBullet throttle. What was that? Throttle and steer. Okay. Yeah, so far so good. So again, let's run this again. We have PyBullet. PyBullet and PPO are not compatible. So in order to run PPO, we're going to wrap PyBullet with Gymnasium. Gymnasium is going to help us feed PPO, the lidar, the position, and the movement of the robot. Okay, hey, Hector. Hector without an H. Well, you know, I'm not, yeah. Here in Mexico, Hector are with H. Cool, okay. So, lidar, position, movement. Feed it to PPO, and PPO says, hey, maybe I should go backwards. And then we say, hey, don't go backwards. That's a bad model. Don't go backwards. So it starts to learn. It says, hey, if I hit a wall, I'm punished. If I go backwards, I'm punished. But if I go forward and I stay alive, then I get rewards. And while it learns, it'll move the robot by feeding PyBullet again, throttle and steer. Both throttle and steer are the ones that move and steer the car. Yeah. So far so good. Any questions before we go to the actual code of this? Nope, all clear. Yes, I'm going to explain what PPO is in a second, but let's just go first and then I'll explain everything. Yeah, all good, all good, okay. Next, okay. Cool. So, let's start importing okay, I'll get to it in a second. Gymnasium as gym, gymnasium as gym. From Gymnasium, import spaces, very important. Import numpy as np, import PyBullet as p, and import map. Okay, now you can see it has a squiggly line under it. Okay, so let's do pip install. Both Gymnasium or only Gymnasium and numpy, I think. And numpy. Let's do Gymnasium first. Gymnasium and numpy. Is it like this? I don't know if Gymnasium is good. Yeah. Okay. Cool. So far so good. It's installing. It takes a little bit of time. Okay. So let's just give it a moment. Let me just double check because that was weird. 88 degrees of my CPU. That's horrible. What? That's horrible. Wait a minute. Let's do this. Ventilation auto. Can I get it to go down? Yeah, I can. Let me just do this max for an instance. Give me like 3 seconds. Should go down. Is it the thermal paste? I changed the thermal paste like a couple of months ago and it was good. Shouldn't be that bad. Why? Like, I get it. It's using this. Shouldn't be that bad. Let's regulate it again. Okay, Hector says, I know it's kind of weird, especially if weird specified everywhere. Yeah, that's fine. Cool. Okay, 74 degrees. That's weird. Let's just keep it open. Maybe closed. Okay, cool. So we have gymnasium, even though we have this squiggly line again. Yep, all should be good. Okay, cool. So squiggly line, because it doesn't recognize should it be, I think it's this one, stream env scripts like Python. It's weird. It should be in part 2. Okay, never mind. It should work. Okay, sometimes Visual Studio Code doesn't recognize the libraries by itself the first time. So let's have it. There you go. Let's have it think a little bit. Okay, let's do a class called car env. Okay, like this. Inside of the class, something that a lot of people, I'm pretty sure, haven't seen is gym.env. I'm sorry, it's env. Okay, what does this mean? It means from gym.env, I'm going to inherit lots of things, or the whole class, and I'm going to create a class that can use the inherited functions or methods from this class. Okay, so this is parent class, this is child class. Okay, so for example, say that I have a class called, let's call vehicle. Like this. And then inside I have, I don't know, wheels. I don't know, def. Let's say it has a motor. It has to have a motor. Okay. Like this. And then print, I don't know, return. It's just for demonstration. Okay. But a car, yeah, exactly. Yes, Tammy, it's OpenAI. Yes, it's very interesting. Okay, if we have a class car, we can inherit from vehicle. Yep, from this class we inherited, and now we can say, hey, I have a motor, but a car also has, I don't know, tires. Okay, so def tire or wheels. Okay, so if I add stuff to vehicle, a vehicle can be an airplane, it can be a helicopter, it can be a car, a bike, I don't know, a scooter, whatever. All of them have a motor. Okay, but something that maybe only a car has, you know, just for demonstration, is a wheel. So I inherit the motor from a vehicle and I add wheels to the car. Make sense? So that's the same issue or thing here, is that from this environment, I'm going to inherit a gym environment for me to work with. Okay, cool. So def under init, my bad, init, we have self and simulation. Okay, so inside of this, we have to init the inherited class. Okay, so inside of gym.environment, we have another init. The way we run this init before we run car environment is we use super. Super is the keyword to say, hey, you class child, I want you to call class parent, yes, and run init. Okay, we run the init of this, but not of this. So this runs first. Okay, what happens if we don't? For example, if gym.env has something called action space, like this, it won't recognize it because we haven't run this yet. We have to run this, initialize it, and then we can use stuff. Okay, so that's what we'll do. Super that's dunder init, like this. Okay, so we started this init, and then create the simulation. So self dot sim equals sim. Yep. like that. Now, I'm going to explain another thing. Okay, maybe like this. Here, okay, let's do a quick square. Okay, so a continuous, okay, so a discrete numbers are non-continuous numbers, yep, which means it can be, or usually graphs look like this. I said it looks like this. Yep, that's a discrete, or those are discrete numbers, okay? Continuous numbers are like this. Yeah. What does this mean? It means discrete numbers are the only, for example, this could be 1, this could be 2, this could be 3, 4, 5, and 6. Okay, so this is 1. Yeah, discrete numbers are just 1, 2, 3, 4, 5, 6. Continuous numbers can be from 0. In this case, let's say that 0 is also a discrete number. But starting from 0, here we have, I don't know, 0.1, 0.01, 0.2. Yep, all the numbers that are inside here, that's a continuous array of numbers. These red ones are a discrete array of numbers. Okay. Now, both steer and throttle have to be continuous. If we have them as discrete, it's going to be like, hey, I can just turn 1 left, 1 right, 1 left, 1 right, 1 left, 1 right, and it doesn't do anything, right? It's just turning like that, no thinking at all. It's not the same as turning a little bit left, maybe more to the right, left, more right, and that way it learns. Okay, it's like when you're driving. Okay, it's not that you turn your whole wheel every single time. Sometimes you just kind of turn just a bit, and that should do the trick. Same thing here. Okay, we have to make sure that both of these are continuous, not discrete. Okay, cool. So here's the thing: self-let action space equals equals spaces dot box, spaces from this one, box with capital B, by the way. Now, spaces dot box requires the low of the number, which is np array. It's an np array of -1. What does this mean? And let's have them as floats, so it's continuous. Okay. What does this mean? It means, hey, I want to move in X and Y. Okay, always remember, for robotics, the way we do it is we have it like this. Let's have the blue as Z. Let's have the red one as X. And let's have the yellow one as Y. Yep, so Z is always looking up. But we're moving both in X and Y. It means we can move like this and turn. Okay? The wheels that move in the Y direction are the front wheels, which steer in the Y direction. Yep. The other ones only move in the X direction. Yep, it's not that the car is going to start to slide like this. No, it's going to move forward, and depending on the wheels in the front, if they move in the Y side, then they start to turn. Okay, cool. So we're moving in X and Y, and both low numbers, the lowest that we can allow the model to have is -1 and -1. Okay, we don't want it to accelerate to 100 miles an hour. We have it -1 going back or to the right. Okay, now same thing. High equals np.array, and we have 1.0 and 1.0. Yep, So far, so good. We have a low value and a max value. Okay, and these values are, they have to be np.float32. Okay, cool. Now let's just add a note to ourselves here. Create discrete. No, I'm sorry. It's not this continuous arrays for the PPO to move. Okay, cool. Cool. Now we have something called observations. Okay, observation equals, in other words, LiDAR distance. Okay, what does this mean? We go back to robot class, and in here, remember we got something. If the sensor is LiDAR, then we're storing all of the LiDAR distances. Ah, yes, here. So we got it. We are seeing these same distances are going to, thanks to Jim that's wrapping PyBullet, be sent to PPO, both LiDAR, position, and movement. Yep, cool. So let's do the observations. That simulation, which is the simulation that we're going to create in the other side, that place sensors. What is this place sensors? It's this place sensors. Even though LiDAR is by default LiDAR, but let's just, for a sanity check, let's have LiDAR here. Okay, cool. Now, we have the observations dimension, which we'll need later, equals length of self that sim the distances like this. Okay, cool. Nice. Let me double check. I have a message from someone. Everything good? Yes. Cool. Okay, nice. Now, we have to have an observation space as we did with action space. That way, in that space, the model can move by playing with the numbers, and it learns with the rewards or punishments. Okay, and punishment sounds bad. It's just we won't do anything to the model. Like, no model was hurt doing this stream. Okay, cool. Self.observation space. Just models like numbers, and if you subtract the number, it's a punishment. I can assure you the model is fine. Okay. Observation space equals spaces.box. Again, another box type. Inside, we do the same thing. We'll do low equals 0.0 and pi equals 10.0. Now, hey, well, wait a minute. Where did you get these numbers from? Ah, go to robot class again. You can see the ray length is 10. The maximum length of our ray is going to be 10. Then our AI class has to have as the highest value of the observation 10. As the lowest, 0. Our ray can't go, on the opposite direction that it's being thrown. Okay, so if you're, it's impossible. If you just turn a flashlight on, it doesn't go towards you if you're pointing it the other direction. Okay, so 0 is our low, high is our 10, which is the ray length. Now, the shape of this observation box is going to be observation dim, comma. Okay, that's it. Oh, my bad, it's observation dim. Cool. And now, the D type is the same one, D type equals np.load32. Okay, good. Nice. Okay. Now, first step complete. We are able to see and move. Okay, thanks to the boxes. Okay. Now, what happens when the model does something wrong? We have to reset the whole thing. For example, if it hits a wall, it like figuratively dies. It gets punished and restarts. Okay? Every time it makes a bad decision like touching a wall, that's a bad thing, and we start over. Okay? Cool. Now, def reset, double enter here, def reset to self. We won't use any seed for now. If you want to use a seed just to keep how can you say this? Reproduce. You can produce it again. Reproducibility. By the way, what I mean is, if you use a seed, then whenever you use it, it's going to behave the same way every time. If you don't use a seed, it's going to be random every time. Okay, cool. And options equals none for now. Now this function that resets the env and the robot as restoring the observations. Now, why do we have to restore the observations? If we don't, then our model is going to learn from a previous life with no new observations. So we have to reobserve. Okay, cool. So that's the reset function. Super, yes, dot. Again, when you use super, it's because you're calling a method from your parent class. Okay, super dot reset and seed equals seed. Yep, we'll do it random this time. Cool. So we have to reset the position and orientation, because gymnasium is for robots and for simulation. Then we already have something called reset base position and orientation here in PyBullet. Self.sim.box ID. What is this box ID? This simulation is this simulation right here. Okay, box ID, remember, is where is the spawn robot? What the heck? Where's spawn robot? Here? There we go. Box ID, it's the robot. Okay, so we call the robot here. Yep. Self.sim.start position. We have it there too. Self. By the way, this is not an equal sign. Self.sim.box ID. Self start position and orientation. There we go. Like this. Wait a minute. No. This is not here. Wait, what? There we go. This self.sim.box ID was running in the wrong method. Self.start position. Self.start orientation. Like this. Okay. Cool. We reset it to these parameters. Then we have to reset the velocity. Okay. We had a angle velocity. We had a motor velocity for the wheels. Let's reset that. Reset the robot velocity. P.reset base velocity, like this. And inside self.simulation.box ID, which is a robot, the first array is 0, 0, 0. The second array is 0, 0, 0. So everything's in zeros. We don't move in both X, Y, Z, in position and orientation. Okay? Cool. Now, when we reset, we have to reread again the first observation to make the first decision. And from there, it's a chain reaction. Okay? So get the initial observation of the sim that place sensors. Again, simulation is going to be this simulation right here. And here we have place sensors. Okay, so we're calling it from here. And see, it's easy because you know that this works. Awesome. Yeah, I mean, no worries. Thank you so much for staying, and you can watch it later. It's always on YouTube. Okay, take care. Bye-bye. Nice time is always here with me in my streams. Okay, so we were self.sim.play sensors. Always lighter, just in case it's a sanity check. Cool. Now observations equals np.array, and inside solve the distances, and it's the d type equals load 32, like this. ONP. There we go. Okay, so we get the first array of observations. It's the distances that we have right first when we just launch the race. Okay, and it's a float 32. Cool. Now we return observations and an empty dictionary that we'll use later. Okay, cool. Now next function is step. Step, as the previous function step here, is the one that takes and makes sure that every single step makes sense for the environment. Okay, so here it says step self and action like this. Okay, function that takes care of the steps in the simulated environment like this. Cool. So first thing is we have to move the car, right? Like the car has to be moving all the time. Okay, apply movement to the car. Okay, throttle equals float its action in 0. Yep, first action in G. I'm sorry, in X. Okay, so throttle, which is your X movement, and we do it times 5. Yes, we're allowing speeds from -1 to 1, so maximum speed is 5. The one that we were using in the demo before, I think it was 20. Yep, there you go. It was 20. So it's going to be relatively slow, but I think it's a good starting speed. We could increase the speed as the model learns. Yes. I don't know. Let's just leave it with 5, so it's not that chaotic. Okay. Nice. Now, steering equals loads of same thing. Action in 1. Action in 1 is Y in the Y dimension, because remember, wheels or steering wheels move in the Y direction. They do not move in the X direction. They move in the Y. Okay. Cool. So stop that. Sim did apply. How about? What's wrong with my spelling again? Motion to car. Throttle. Steering. Yeah, and see that? That's why I created 2 scripts. Apply motion to car. It's here. It's this one. Yeah. And again, we know that this works, so we'll just passing the data from one script to the other, and that's it. Yeah, it's super easy. Cool. Okay. Did I sound French there? I don't know. I feel like I went like, yeah, it's super easy. By the way, I speak French. Okay, so yeah. No offense to the French people. I speak French. Je parle français. Yeah. Sometimes I don't know. My accent gets the best of me, so I say, yeah, it's very cool. It's not very cool. Okay, it's very cool. Nice. Shout outs to people who speak French or live in a French-speaking country. Cool. Why do I speak French? I speak actually 5 languages. FYI. If y'all want to guess which languages I speak, okay, so English, French, and I speak. Yeah. So you're missing 3. Anyone want to try and guess? Cool. Okay, so while people are guessing which languages I actually speak, simulate with 50 steps. Okay. Yeah. You're good. All right. That's Spanish because I live in Mexico, so that's 3. English, Spanish, French. What else? Italian. Ooh, that's not a bad guess. I actually learned Italian in college. I had like A2, which is a level A2 of the language. But no. Japanese, that's one that I want to learn, but no, sadly no. You're kind of close. Beep Beep is closer. Okay, who's closer? Geographically, I'm going to call you JA. JA is closer geographically than Beep Beep. Yeah, Karima says Chinese. Yeah, no, Chinese, no. I want to learn Chinese too, though. Okay, try to guess. Geographically, Italian is closer. Cool. Okay, so 4 underscore in range. 50. Okay, so 50 steps. German. Ooh, that's not a bad one. I can understand German. I studied German for like 3 years and then I stopped it. And for everyone who speaks German or is German, with all due respect, and close up time. Okay, close up time. You speak weird. Okay, so for example, if we say Greek is not bad. Greek is not bad. I don't speak Greek. For example, if German people say, I'm going to eat cake. Yeah, I think you can say cake. I am eat going, and it's like, yeah, no. I think Japanese is sort of like that. Like you can like the order of action and like subject and action, it's on the other side. So it's like I'm like eat, I'm going. Like Yoda, yeah, eat, I'm going. Stuff like that. Sadly, it's not Greek. Okay, I'll help you with one. It's Arabic. I know how to speak Arabic. Fun. And because I know how to speak Arabic, I also know how to speak Lebanese. My family is Lebanese, so yeah. Those are languages. Lebanese, Arabic. Lebanese is not a language. I'll just consider it one. Lebanese, Arabic, French, Spanish, and English. No, I do not know Portuguese. Because of the Spanish, I can kind of understand Portuguese. But no. But good try. Thank you, Jay. Nice. Okay, so getting back to the steps. Okay, we have 50 steps for each step. That step. Simulation. Okay, so the simulation is going to be controlled here. It's not going to be controlled in the other side. Okay, let me turn my light on because the sun is just going down. That's better. Cool. Nice. So we have to place a sensor, right? Like we placed it here, but after a step, we have to replace the sensor and reread. Okay, so the sensor is not like a physical sensor when you put it on and it stays there. If you put it on one frame, it disappears in the other. Yep, it did its thing, which is measure its surroundings, and then it disappears because you didn't say, hey, I wanted to read again, and I wanted to read again, so on every single frame. Okay, so place a sensor. Self.sim dot place sensors, and it's lighter. Again, sanity check. We put lighter. Okay, cool. So observations again equals np.array, and it's self.sim the distances, and then d type equals np.load32. And there we go. Now compute the reward. So we have to create a reward function too. We have time. We have time. We have plenty of time. Yeah, 3 more functions and we are over. Observations. There we go. Copy the reward. Reward equals software compute reward. Like this. If we crash, the simulation should end. Okay. Done equals self that is colliding. Okay. So we have a done variable, and if we collide, done is true. And if we're done, then return OBS reward done false and like this. Okay, now you'll see why. And you'll see done. We'll get to know if done is done. So we finish everything. Okay. Now, def is colliding. Okay, and I was stuck yesterday with this for a moment because what? No. I'm sorry, the hotkeys of Visual Studio, I don't get them. Control C, Control C, Control C. There we go. I'm sorry. Was it Control T for terminal? What did I press? Control K? No. Yeah, I think it was Control K and then something. Control K T. I don't know. Cool. So it's colliding. Check if the car has collided. Okay. So, by the way, careful with the ground. Okay. So, control plus that thingy. I don't know how to put that thingy. Oh, I get it. Control plus that thingy? Really? Nope. Like maybe in your keyboard, but in mine, no, because it's under the plus sign. Yeah, I don't know. It was weird. Okay, careful with the ground. Now, colliding with something, we are also all the time colliding with the ground. So yesterday I was stuck like that because the car kept spawning and despawning and then spawning again and despawning. And I realized it was the ground. Okay, so we get contacts equals p dot get contact point like this. Body A, which is the first body, equals self dot same dot box ID again, which is your robot. And then for C in contact. Okay, by the way, I'll just get the contact point of the robot. What's wrong? Go back. There we go. Cool. So for C in contact, other body equals contact into. Okay. Cool. So we have to, I don't know, enter there. We have to ignore the ground. Okay, cool. If other body double equals self dot sim dot lane ID, then continue. It means we don't care. Return true if we contacted something. Okay, if it was the plane ID, then no. Okay, why can we do this inside? So the first iteration will give us the first contact points of the ground. Okay, so it goes from down up. Okay, cool. And now, if the for loop has passed and no return true was made, return false. Okay, it means no contact. Okay, only with the ground. Okay, nice. Now, going to something not very. Yeah, no, it's gotta be easy. Compute reward. Self. And then function that computes the reward of the action made by model. Cool. So we have something we don't care, which is position. We have orientation equals p.get base position and orientation of our robot. Okay, so we get this. And then we get the velocity and a parameter that we don't care, which is p.get base velocity and itself. That's same that box ID. Okay, so we're getting the velocity, both velocity and orientation of this. And with this, let's calculate what's a forward. Okay, so we did this in the past stream where we said, hey, for the race, it's not like the simulator understands what a ray is. It's like, yeah, I'm going to shoot a ray and it's going to look forward, and that forward is relative to where I'm looking at. Yes, it can be there. In this case, it can be there. Okay, cool. So let's see. Do I have a new message? Yeah, my grandma. Grandma always texts. Forward direction. So we get rotation matrix, and she sadly doesn't watch my streams. Post p.get matrix from quaternion. This function, weird function that we explained last time. Now that's the forward direction. Now get the forward pointer. Now forward equals from this rotation matrix. Remember that the forward is 0, 3, and 6. We have 9 things here, or 9 pieces of data. 3 of them are forward, which is 0, 3, and 6. Okay, those are the indexes or indices. So it's velocity in 0 times forward in 0 plus velocity in 1 times forward in 1 plus velocity in 2 times forward in 2. Okay, cool, awesome. Now, oh no. By the way, yeah, I was like, what? This is the forward speed. That's why we're multiplying with forward. Okay. Forward is the 3 things that I mentioned, which is rotation matrix. In 0, we said rotation matrix in 3, and rotation matrix in 3, 6. Okay, cool. And this is a projection of the velocity into the vector. Okay, cool. Now we just projected the speed there. Cool. Okay, now we get a base reward. The base reward is going to be the speed. Okay, which is reward equals forward speed. Okay, that's the base reward. Now, that if it goes back or in reverse. Okay, it's really bad. So let's actually do this. Oh, it works for me because I have what was it? What's the extension that I had for this? This one, better comments. Okay, so it works for me. Okay, I'll keep it like this when it's bad, and when it's good, I'll do darn, what was it? Let's see. A large way to do. Oh, yeah, another an asterisk. There you go. So green for me is good. This one is bad. Okay, but I have better comments. The extension of better comments. Okay, if you don't have it and download it in Visual Studio, you'll see them as usual or regular comments. But just for the stream, okay, it works. Okay, if you want, go download this one, and yeah, it's really cool. Really helps because if you write to do like this, it just colors it with another color, and it's helpful. Okay, cool. So bad if it goes back. Okay, so if forward speed is less than 0, which is it's going back or backwards, then reward minus equals, we're punishing it, 5 times the absolute value of forward speed. Okay, yeah, so far so good. We're subtracting. In another way, subtracting is punishing in the model. Again, no models will harmed during the stream. We're punishing it by subtracting some numbers from the reward. Yep, if it goes back. Okay, cool. So we need the model to understand that getting too close to a wall is bad. Okay, we needed to understand that it doesn't have to go near walls. Okay, so if actually, let's get if it goes near a wall. Okay, so min distance equals min itself dot sim dot distances. Okay, so we get the distance, and now the minimum distance. If the minimum distance is less than 1.0, yes, then we're too close to something. So let's not do that. Reward minus equals, and let's do relative to. It's how can we say this? Relative to the distance of the ray and the wall. Okay, so should be 1.0 minus min distance. Yep, because it's less than 1. Okay, so it's not a very bad punishment. Okay, cool, awesome. So if we collision, if it collisions, if stuff that is colliding, so if we collided with something, then this is bad. Reward minus equals, subtract 20 points like that. Cool. We give it a bonus of staying alive, which is not colliding. If it's alive, so self that is no, I'm sorry. Reward plus equals 0.05, like this. Okay. And after this, now I know I said, hey, if it goes forward, it's a good thing, but we're already punishing for backwards, so it'll be redundant if we say, hey, go forward. Okay. In the end, here we have the punishment. Okay. If it stays alive, it's a 0.05 reward. Okay. So not colliding and staying alive don't necessarily redundant themselves just because one subtracts 20 and the other 0.05. Okay, cool. Now, yeah, that should be good. Oh, wait a minute, we're done. Okay, last function. Def is done. Literally. And now, function that checks Is stationary allowed? No, it shouldn't be, and it can't stay. It can't stay stationary because the forward speed would be 0, so it doesn't get a reward. Yeah. So when it moves a little bit, this goes up, and PPO automatically understands that staying, without moving or stationary cannot be allowed because it wouldn't get any rewards. Okay, maybe this get alive, but that's why it's a 0.05. Yeah, but this is the big one. Okay. Yeah, good question. Function that checks if we have collided or not. If we did, it's done. Wait a minute, we don't use this one. This is a redundant one. Wait a minute. Why do I have 2 of these? No, wait a minute. This is good. Yeah. Or not. Wait, because do I use it in the other? I think I use it in robot class. Wait a minute. Beep, 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 beep. Nope. Yep. Nope. I don't know why I had that function there. Okay. Cool. So we're over. AI class is all good. The squiggly lines are weird here. I don't know why. Okay. Am I in part 1 or part 2? No, it should be good. Okay. So now next thing is everything here is good except this part over here. Okay, we need to redo it. So track points are good. Okay, the walls are there. First things first. Let's do. Oh, by the way, we have to import the class. So in here you do import AI class as AI like this. Okay, so it automatically understands that this AI class, it's this one. You see, if I rename this to AI class with 3 S's, then AI class. Oh, there we go. It by itself, Pylance corrected me. But yeah, see, it wouldn't recognize it if it's just, for example, with 2 S's in this case, or 3 S's, it recognizes it. Okay, cool. I'm going to change this, just in case. Wait a minute. F2. There we go. That should be good. Okay, cool. Now we have that AI thingy. First thing that we'll do is simulator. Oh wait a minute. We have the simulator here. Yep, this is okay. So far, so good. We defined the domain tracks. We have the simulator running. Now, next thing that we have to do is spawn the robot that we have it here already. It's a race car. Okay. And now we create the walls. Okay. Let me just charge my computer. Now it's asking for some juice. There we go. Now we spawn the robot. We create the walls. So simulator.create walls. And then we will place the sensors ourselves only for this time. Just once. Okay. Simulator.place sensors. And sensor equals lighter. Yep, sanity check again. I know, but just for it, okay? Now, next thing is we're going to do this thing. We're going to wrap PyBullet with Gymnasium. The way we do it is wrap PyBullet with Gym. Okay. So env, which is our wrapped environment, is going to be AI, which is this AI class dot car env simulator. Okay, we get the simulator as our input, and then we won't be running the run simulator ourselves. It's going to do it in here with this step function. Okay, so use PPO model. So model equals PPO, and we're going to do MLP policy. Why don't I have PPO? Oh, I need stable baselines. Wait a minute. We'll download it later. Let's just finish this part right here. Where in the env, verbose equals, let's have a 0. I don't want my my terminal to be full with junk. And then model.learn, literally total times steps equals, I'll do 50,000. Okay, is it 500,000 there? 1, 2, 3. Yep, 500,000 is good. Okay, cool. Now PPO, you can see it has a squiggly line. So we do from stable baselines 3 import port PPO, like this. Okay, go to your terminal and do pip install stable dash, not underscore, dash baselines 3, like this. Yep, there we go. It should be cached for me. It takes a little bit of time. Okay, it's pretty heavy. Okay, in the meantime, we can see it here. Yep, my computer is good. Is it overheating again? I hope it's not. 88 degrees, that's not good. Can I... Is it reading okay? Let's see. 92 degrees? That's not normal. 96, that's not good. Yeah, that's weird. 83. Okay, I don't like the spikes of that. Maybe I'll change the thermal paste this week. Yeah, okay. Okay, it's still downloading. It takes some time. But yeah. Let me just grab a little bit of a breathe there. Is it going to rain? I don't know. Let's see. Yep. 19 out of 22. Come on, come on. Let me just close. Maybe I'll screenshot this and I'll put it on GitHub. And just close this so my CPU doesn't get overloaded. Yeah, don't save. No worries. I think I can put it right here. There. Saved. Cool. Now. Oh, good. We got it. Now, I don't know why this squiggly line doesn't go away, but let's see if it works. So, fingers crossed, 3, 2, 1, Pi to be robot class, okay? Robot class will call AI class. Ready for the errors? I'm ready. I said, ready for the errors? There we go. Yep. Yes. First error of the day. No, it's like the 4th. Self.env.observation space. Observation space. What? Did I write it wrong? Observation space? Really? Am I that dumb? Wait a minute. That is Observationspace. See that? No S. Observation space. Now this is wrong. We have unit partial, so you might be in different folder instead of VS Codes. It's weird. I don't know, because yesterday it worked. Like yesterday it didn't get the squiggly lines, or at least for example in NumPy or PyBullet, when we installed them earlier today, the squiggly lines just disappeared. So I don't know. Maybe I don't know. Like maybe you're right. I'm not sure. Okay. Let me get space here. 2, 3, 4. Oh yeah, all should be good. It's observation space. Here it's yeah, should be good. And observation space. Yep, should be good. Cool. Awesome. It's working. Will it work? Wait a minute. Nope, it doesn't work. It says self start position. Car EMV object has no start position. What? Car EMV doesn't have a starting position. Which line? 44. What? AI class? Oh, I think it's self.sim. Wait a minute. That's sim. Good. Yeah, that should be good. Let me just double check that. AI class cheat sheet is here. Let's see. I'll go here. Line 44. Yep, missed the sim there because that sim is referring to robot class. Let's see. Okay, okay, it's doing something. Can you see this? It's going a little bit slow. But let's see if we can enjoy this. Okay, so it's not moving that much. It's not knowing what to do. Oh, maybe I'll do this. Wait a minute, I have an idea. I'll remove this. Wait a minute. Stop screen. I'll put you all here. I'm sorry. And then the simulation should go to my other one. And I guess it's a refresh rate. Yeah, can you all see this? Yeah, that's way better. So the card's moving, okay? It's moving randomly. It should take some time, so it lives for a certain time, and then it dies. Okay? So, and it learns from that. Okay? So PPO takes care of learning. Yeah. Come on, you can do something. Yes, it's when it goes back, it realizes that going back is not good. And if it goes forward, for example, in this direction, then it's getting too close to that wall. Okay, by the way, this is a very, very simple RL. Like we can add way more observations, but for this stream, I think it's good. Okay, it stays in the middle. Come on, come on. It takes time to learn, okay? So we can have a chat in while it's learning. But yeah, you can see that it went from here, from this point here, all the way up to this point. Okay, and maybe it's realizing that the green rays are the ones to follow. Can you see that? It's kind of pointing there in the reverse, so it's pointing reversely. Okay. Maybe 500,000 time steps wasn't good. It hasn't died. Okay, so like 500,000 frames have to pass. So give it some time. Maybe I have an idea. Wait a minute. Maybe we can do. Okay, I'll just put this here. Maybe we can do. Maybe 50,000. So it's way less, and let's just speed things up just to see what happens if I remove this. So time.sleep 1/240. PyBullet goes at 240 hertz. So let's see if that doesn't create crazy things. And there you go. It should be super fast now. Yep, can you see that? Now it's like the rays are all chaotic. But it should maybe learn easier. Okay. Maybe I should make the race invisible, have that function. So we have 7 minutes. I don't think I'll do it, but maybe if you want to do it for the future. Oh, there we go. It did something there. Okay, it respawned. So we touched a wall. It respawned here. Respawn again. It's touching a wall. It has to learn. No touching the wall. See that? Now it's going forward. It's going to that wall. It says maybe the other one is not mortal. Nope. Nope. I'm going forward. Going forward. It says, nah, I really want to touch the wall. Maybe if I touch it here, nope. Do not touch the wall. There we go. It's going forward. It's going to touch it there. Nope. Come on, it's going to learn. Nope, don't go there. Okay, it went back. It says, hey, maybe the wall in the back is not bad. And it is. All the walls are bad. Now, maybe if you want to continue with doing something else with this, what you can do is add checkpoints. So for each checkpoint, when it passes through the checkpoint, you give it a very high reward. So it knows that it has to go through the checkpoint. See that? Now it's getting really far, but there's a problem. If it gets far, you can see all of the rays are red now, but some will turn green here when it gets too far, and reinforcement learning algorithm will get confused because we don't have checkpoints. We don't have a goal. We don't have anything. We're just waiting on it to see if it can drive. So if it can stay alive without touching a wall or doing something, then it's good. And it did. Can you see that? It touched the wall now, but it's getting far now. It's going to touch the wall now as I speak. Oh, there we go. See that? So there we go. It's getting far, but the rays on the back are getting green. And we're punishing it if it goes backwards. Yes, because this is not a track. This is just a box. Okay, so maybe the next step would be close up time, add a goal, add checkpoints, and add, if you want to add goals, add or like create a track so it can follow, and whenever it hits a certain coordinate, it's a checkpoint and you give it a reward. So it knows that it has to go that way. Okay, that's maybe what you can do. Cool. So I'm going to stop this. Yep, the car is there. It's like, yep, I don't know what to do. Like you told me to go backwards is bad. I'm staying alive basically. Yeah. So, and because the stationary is not an option, then it kind of moves a little bit. But yeah, you can see that. Yeah, awesome. Cool. I'm going to close this. I'm going to change the screen. No, I'm going to stop this. No, let's do something before. Please, I want you to register here. And before we wrap this up, by the way, the code will be on my GitHub today. Okay, the part 1 is there. Part 2, which is this one, is going to be there today. Okay, so you can use the code. Cool. Okay, so there's the feedback link. If you could please go to that link, click on continue, and then it's train on autonomous vehicle part 2. There you go. Train on autonomous vehicle with PyBullet part 2. That's mine. Rate the stream if you feel like it was really good, a 10-star. If you really think that it stank, a 2. I don't take it personally. Don't worry. It makes me a better streamer. Okay. So if you could, spend 2 minutes of your time by just filling this feedback form, I'd really appreciate it. Okay. Cool. Lots to learn. Yeah, beep beep. Reinforcement learning is really interesting. You can have there are genetic algorithms, the ones that create swarms, and then the best of the swarms get duplicated, and the ones that decide the best get duplicated again. It's really fun, okay? But you have to understand core things too, okay? Awesome. Hello and goodbye. I'm wrapping this stream up. You are in good hands because next one is Jocelyn. And Jocelyn is a robotics engineer too, one of the greatest minds that I know. She'll be streaming Build Your Own API using Fast API 101. Okay, so yep, if you want to watch Jocelyn's stream, that'd be cool. Awesome, and thank you, Ireland. Have a nice one, and yeah, I'll see you tomorrow for Data Science 101 with pandas. Okay, don't miss it. I'll see you tomorrow. Take care. Bye bye. Joss, I'll leave it to you.